Okay, so let's talk a little bit about this other tool called the law of cosines, which is basically just a generalization of the Pythagorean theorem. I'm gonna go ahead and drive this again, and if you're not interested in the derivation, you can skip ahead. So let's start with, so I've generalized the black triangle is the one I'm interested in, but I've extended it out to make a right triangle, because then I can use the basic fact that cosine theta equals the adjacent side, which is b plus x over the hypotenuse. And now I'm going to look at these two other facts that I can say. The Pythagorean theorem, b plus x squared plus h squared equals a squared. And also x squared plus h squared equals c squared. So now I'm going to start plugging this all together. I'm going to start with this guy. I'm going to kind of FOIL this out. B squared plus 2bx plus x squared plus h squared equals a squared. This is disgusting. But it turns out that x squared plus h squared is just c squared. So that's a help. B squared plus 2bx plus c squared equals a squared. And then I got this 2bx term, which is my kind of, the way I think about it is, b squared plus c squared equals a squared. That would be what happens if you have a right triangle. This 2bx is basically an adjustment term that fixes the fact that it's not a right triangle. Well, I'm going to use this factor to link together cosine b and x in a way that I can rearrange this. So let's take a look at what happens here. I'm going to multiply by a first. So a cosine theta equals b plus x. And I'm going to get rid of b. So now I have x equals a cosine theta minus b. So here we go. 2bx then is 2b times a cosine theta minus b. So I'm looking at 2ab cosine theta minus 2b squared. So this 2bx term I'm going to replace with this. Here we go. B squared plus 2ab cosine theta minus 2b squared plus c squared equals a squared. This turns into minus b squared. So I'm actually going to bring everything across to the other side except for c squared. C squared equals a squared plus b squared minus 2ab cosine theta. Theta is the angle between a and b. This is the law of cosines. Okay. So how does it work in practice? I'm just going to erase here because I need that, but I might as well keep my beautiful triangle. I wish Zoom had a triangle tool. Okay, so let's say that I know information that is not going to work for the law of cosines. So this is 100 feet. This is 130 feet. And this is, I don't know, 36 degrees. So again, we got a problem with the law of sines because there's no pairs that are possible here. But the law of cosines would work fine. In fact, it's set up so that there's no algebra needed. It's just a squared plus b squared minus 2ab cosine of the angle between them. So from here, it's just a little bit of computation. Sometimes I see problem with students with problems in order of operations, especially if the angle's missing, right? All of these things are linked together by multiplication. So 2 times 130 times 100 times cosine 36, and make sure, of course, that you're in degree mode. So that's 21,034.4. I got 130 squared. I got 100 squared. And then c squared equals 5, 8, 65.6. So C equals 76.6. Beat. Done. That is the law of cosines in a very fast little nutshell. Now, the law of cosines is flexible too, and I can solve lots of triangles. In fact, in some ways, the law of cosines is more flexible than the law of sines. And we'll look at some more application problems involving that in the next video. All right, I'll see you there.